In this session, we are going to learn an experiment to find the specific latent heat of fusion of ice and the specific latent heat of vaporization of water. First, let's see the experiment to find the specific latent heat of fusion of ice. In the diagram, A and B, the setup are similar, except that for A, the heater is not connected to the joule meter and the power supply. When the heater is switched on, heat released by the heater will be absorbed by the ice. Also, since the air temperature outside is higher than that of the ice, therefore, there is another heat source, heat absorbed by the ice from surrounding. In order to eliminate the effect due to heat absorbed from surrounding, we need to have a control experiment. Okay, the control is used to measure the amount of ice melt due to the heat absorbed from surrounding. After the heater is switched on for a few minutes time, it is switched off. Let E1 be the initial joule meter reading, E2 be the final joule meter reading, M1 be the mass of water in beaker A, M2 be the mass of water collected in beaker B. By the equation, we have energy absorbed by the ice at its melting point, 0 degrees Celsius, is equal to the mass of ice melted times the specific latent heat of fusion of ice. That is to say, E equal to M L F. The energy absorbed by ice, E, can be found by the energy released by the heater, which is the difference between the final joule meter reading and the initial joule meter reading, which is equal to the mass of ice melted, M, is equal to M2 minus M1, which is the mass of ice melted by the heater alone, LF. Therefore, LF equal to E2 minus E1 over M2 minus M1. Substitute E1, E2, M1, M2 into this equation. We can find the experimental value of LF. Since there is heat loss to surrounding by the heater, therefore, the mass of ice melted by the heater, M, which is equal to M2 minus M1, would be smaller than expected. From this equation, we see that since M2 minus M1 is smaller, therefore, the specific latent heat of fusion of ice melt in the experimental value would be larger than the specific latent heat of fusion of ice, the standard value, or the true value. There are some improvements for the experiment to increase the accuracy. The first, we should use crushed ice, okay, in order to increase the thermal contact, between the ice and heater. Therefore, the heat loss to surrounding will be decreased. Second, we should wait to start the experiment. We should wait until we see some water is dipping out from the funnel. Since in this case, we make sure that the ice is melting, because we are going to find the specific latent heat of fusion of ice, that is, the change of state occurs at 0 degrees Celsius. When the ice is melting, we make sure that the ice is at 0 degrees Celsius. Therefore, the energy released by the heater is used only to change the state of the ice, not its temperature. Thirdly, we can wrap the funnel by using cotton, by using cotton to reduce the heat loss to surrounding. Therefore, this will improve the accuracy of LF fan. Next, we are going to do an experiment to find the specific latent heat of vaporization of water, LV. Specific latent heat of vaporization of water is the energy needed to change 1 kg of water from liquid state to vapor state at its boiling point, that is 100 degrees Celsius at 1 atmosphere pressure. The procedures for the experiment are: first, we put a beaker of water on top of an electronic balance. Second, we place the heater of power P into the water. Thirdly, we switch on the heater to heat the water. Fourthly, when the water starts to boil, start the timer and measure the initial balance reading, which is M1. Fifth, after the water is kept boiling for a time interval of T, we switch off the heater and measure the final balance reading M2. Without using the thermometer, we can determine when water starts to boil. When water starts to boil, you can see a lot of air bubbles coming out from the water. Now, in the calculation, we have energy absorbed by the boiling water equal to the mass of water vaporized times the specific latent heat of vaporization of water. If we assume that the energy absorbed by water is equal to the energy released by the heater, therefore, we have energy absorbed by boiling water equal to P times T, which is equal to mass of water vaporized at its boiling point, is equal to M1 minus M2 times specific latent heat of vaporization of water, LV. Therefore, LV equal to PT over M1 minus M2. By substituting the value of power P, the time during which the water keeps boiling T, and the initial and final balance reading M1 and M2, we can find the experimental value of LV. There are some errors in the experiment which will affect the value of LV found. The first is that there is heat loss to surrounding. Therefore, mass of water vaporized will be smaller. Equation we have M1 minus M2 will be smaller. Therefore, the experimental value of LV will be larger than expected. To reduce this error, we can wrap the beaker with cotton or wool to reduce heat loss. The second error is that some water vapors at the top of the beaker will condense back to the beaker. Therefore, mass of water vaporized is again would be smaller than expected. Therefore, the experimental value of LV is still larger than expected. The third error is that some water spills out SPILL, spill out of the beaker before boiling occurs. In this case, the mass of water vaporized would be larger than expected. That means M1 minus M2 will be larger. Therefore, the experimental value of LV found will be smaller.